Okay, to kick off section 4.7, we really need to review an important skill we did in section 4.4. So this could be your reference for this, where we used reference angles to find the exact value of these trig functions or trig expressions. Okay, this one though, when it's quadrantal, we just use the unit circle and a coordinate of 1, 0. But if they're not quadrantal and they fall in a quadrant, just a quick reminder, what we do is we draw a reference triangle with the x-axis and the appropriate sides, and then we create a reference triangle. So for example, like 135 degrees, we draw that angle, figure out the angle with the x-axis, and then it becomes a 45, 45, 90 relationship. 1, 1, square root of 2. And then I can find the sine or cosine. In this case, they ask for 3. But we can find any of the 6 trig functions if you have its reference angle. Okay? So that's what we're going to review because it is critical. If you can't do this, then you can't do section 4.7. But thankfully, a lot of you guys did very well on this skill in 4.4. We just have to knock off the rust and review it so that we are ready for section 4.7. All right, so you should pause the video at home and try 1, 2, and 3 to kickstart 4.7. Okay, here we go. So 3 pi over 4 is 135 degrees if you convert it, or you can just think 3/4 of pi, and pi is a straight angle. So 3/4, and I'm left with pi over 4 as my reference angle. Okay. So if this is a 45-degree angle with the x-axis, this must be leg, square root of 2, or 1, 1, 1, square root of 2. Remember, if you're not in the first quadrant, one of these x's or y's must be negative, or maybe both. So negative x, positive y. Now I can find the cosine. Adjacent over hypotenuse, x over r. Okay, number 2, pi over 3. So that equates to 60 degrees. So we end up with this 30, 60, 90 relationship. Opposite 30, time to get this memorized again. Opposite 30 is always the small leg. Small angle, small leg, small side. Okay, bigger angle, bigger leg. This is like 1.7. Okay, now that we have it set up, now we can find any of the 6 trig functions, in this case tangent, so square root of 3 over 1. All right, and then 3, an angle of 0 ends where it started, right? Didn't move. So we keep it here. No reference triangle we can draw for these. We need to rely on the unit circle coordinates, so radius of 1, meaning this is a coordinate of 1, 0 on the terminal side. So by sine, it's y over r, so 0 over 1. We get 0. Okay, these skills will be imperative for 4.7. If you didn't know how to do any of those, that's a problem you need to fix. So you need to go back to section 4.4 and review that and get it down, okay? I wrote it down right here, section 4.4. Okay, a little more follow-up. If you want to try these, pause them and then check them, go ahead. But just another few problems of finding these trig functions. Negative pi over 6 rotates in the negative direction. Opposite 30 is 1, square root of 3, hypotenuse is always 2. More follow-up if you need to, okay? All right, so 4.7 is all about what's called inverse trig functions. Inverse trig functions. Back when we did inverse functions in chapter 1, we usually denote, here's an example, a real basic example of inverse functions. Let's just say we have a number squared, or x squared. The inverse of that, which kind of undoes it, it would be the square root of x. And we denote inverse functions with this little negative 1 up there, okay? All right, so in order for functions to have an inverse function, it had to pass the horizontal line test. So when we first went over this, I kind of started with a little parabola. And we talked about, does it pass the horizontal line test? If it doesn't pass the horizontal line test, it does not have an inverse function. Okay, has to be 1-to-1 first. So that's a problem with the sine function. This does not pass the horizontal line test. Same with cosine. Same with tangents. So what they did in order for those to have an inverse trig function is they restricted the function or the domain. All right. So since the domain of sine is usually negative infinity to positive infinity, they had to restrict it to this. Okay, feel free to write that in there. Domain is all real numbers for the sine graph, and the range is -1 to 1. Okay, but to make sure it has an inverse function, they restricted it to what I highlighted here, from -pi/2 to pi/2. Okay. Here's cosine. Cosine is the same domain and range of sine, but they restricted this one to make it 1 to 1 from 0 to pi. All right, and tangent, don't worry about writing this down if you don't want to right now. We just need to focus on the inverse, but the range for tangent is negative infinity to positive infinity. And then you can see how there's gaps, right? The domain is not all real numbers now. We have asymptotes at every odd multiple of pi/2. Okay? Okay, so the inverse functions, they always interchange x and y. They flip the domain and range. All right, so now that -pi/2 to pi/2 for sine and cosine becomes the y-axis. Okay, and then the range becomes the domain. So we just flip those around. And this is the part that becomes a little more important for today's material. Okay, the range of values for the angle are -pi/2 to pi/2. For cosine, it's 0 to pi. And there's tangent over there. This one has parentheses and the other ones have brackets. That is kind of important. Okay, so instead of this f-1 for inverse functions that we were used to seeing, they're going to represent inverse functions one of two ways. They'll put sine with this little -1. We've seen that before with having to find angles in our calculator. We've had to use that before. Or they may also put arc sine. So I make note of this. It's just another way to represent an inverse trig function. All right, so arc sine means sine raised to the -1. All right, all these x values will be between -1 and 1 for sine. And then the values for y are going to fall in this range. This is probably what you want to write down, but you could put y above it maybe, just above theta. But I want you to understand that this is the range of values for the angle. Okay, so theta can be greater than or equal to -pi/2 or less than or equal to positive pi/2. All right, here's cosine. Same range of values for x. But for theta, it's a little bit different. As we saw on the graph on the previous page, to make it 1 to 1, they restricted the angles from 0 to pi, inclusive. And then the values for x that they'll give you could be a large range of values, but this is the part you have to remember. That's why I highlighted these. You got to know the restrictions on the angle. Tangent graph, remember, has asymptotes at -pi/2 and positive pi/2. That's why I can't equal. There's no line underneath it for tangent. Okay, so for these first set of problems, find the exact value of each expression. It's the only example we're really going to focus on today. So I want you to write down the success criteria that I think will help you be successful on these. Okay, so step 1 says to rewrite the function with the restrictions, which means the angle restrictions. All right, step 2 reads determine which quadrant. So it means determine which quadrant this lies in. And then the third and final step will draw the reference triangle or unit circle to find theta and answer the problem. Okay. Okay, so the first step, once you get used to it, you'll be able to maybe start skipping that, but it helps you realize what we're looking for. When you see arc sine, or it could be sine with that little -1 up here, it means this is what we're looking for. So sine of what angle gives me 1/2? Okay, that's the big picture of inverse trig functions. In section 4.4 in a warm-up, they gave us an angle like sine of 135, and we were looking for this value, right? Now you're given this value, you got to find the angle that gives us that. Okay, that's the point of these problems here. Go in the other direction. All right, now, so I rewrote the function so we understand what we're looking for, and then also want to add the restrictions. So the restrictions on sine are right above. The angle has to be between negative pi over 2 and positive pi over 2. So negative pi over 2 to positive pi over 2. Okay? Step 2, determine which quadrant this angle lies in. All right, let's go back to our A-Smart Trig class to help us figure this out. Okay, remember the angles are still always going to start at the positive x-axis. This narrows it down to 2 quadrants right away. So I'm starting at 0. It could rotate down to negative 90 or negative pi over 2, or all the way up to positive 90 or anywhere in between. Okay, that's what inequality means, right? This range of values. So theta could be in the 4th quadrant or up to the 1st, but these are out just based on the inequality. Next, I can use this to my advantage. Sine of this angle we're finding is positive. So if it's positive, remember, only cosine's positive down here. Tangent's negative and sine's negative. So it can't be in the 4th quadrant. It must be in the 1st quadrant. So quadrant 1 is what I'm going to circle here. We narrowed it down. Okay, and step 3, just take some practice and getting used to it, but it's always going to be one of our common angles. Draw a reference triangle or the unit circle. We don't get 1/2 from the unit circle using those coordinates 1, 0, negative 1, 0. So it's probably happening from one of our reference triangles. So I know it's in quadrant 1 now, so let's go ahead and just dump an angle on quadrant 1 and create a reference triangle. Okay, and from here we just kind of use this backwards. Sometimes if it's rationalized, this can get tricky, but like I said, you're going to get comfortable with it because this angle is going to be either 30 degrees, 60 degrees, or 45 degrees. It's going to be one of our common angles. So just trial and error if you really need to. But since this is opposite over hypotenuse, let's try to put this opposite my angle, 1, and let's put 2 at the hypotenuse. All right, and this is matching our 30, 60, 90 relationship, right? Where it's 1, hypotenuse is 2, and this is always square root of 3. If you're not sure, you could use the Pythagorean theorem to confirm that, but that is correct. Okay, so then what's always opposite our small leg? It's the small angle, 30 degrees. So the answer to this problem is 30 degrees. Typically, they're going to want it in radians. So maybe have it memorized as pi over 6, or remember we can just multiply this by pi over 180 to convert it. That's the 1/6 relationship. The answer is pi over 6. Okay, so just a quick recap. Step 1, I want you to rewrite this so you understand the big picture. What are we looking for? Okay, an angle that gives me 1/2. This tells me it's in the 1st or 4th quadrant. But since it was positive, it couldn't have been in the 4th. So we knew it was in the 1st quadrant. So we go on to step 3 and kind of work backwards to figure out which angle it is. Okay. All right, I'm going to walk you through another one, and then we'll have you try a couple of these. Let's go on to number 2. Step 1, tangent of what angle gives me -1. Is what arctan means. What are the restrictions on tangent? Very similar to sine, but there's no line underneath it.